Okay, so this is part two of transactions. We're going to cover transactions and UTXOs, starting with the raw transaction data. So let me pull this over. So we're going to go back to MemSpace here, and we're going to go into the latest block. We're going to find the transaction. So we'll just let's get the Coinbase transaction. We'll go to this one, and let's look at the details of this transaction. Looks like it's taking a second to load. All right, well, it wasn't doing this earlier, so I apologize. Okay, so these are the details of that transaction. You can see all this, gibberish type stuff. Not really sure how to make any sense of this. What exactly are these? Or we go down a little bit. We can click on this, the transaction hex. It's going to open up a new page. So these are the actual, these are the bytes. This is the raw data, the raw bytes of this transaction. So let me get this out of the way. So recall when we did our exercise that a transaction is it's simply data that is propagating itself through the network of nodes. That's what a transaction is. And so this is the raw data of that transaction that's moving across the network. Now this one is different from the one we just copied from Mempool. I got this one from the Bitcoin Developer Guide. And here's what it looks like. And also recall that this is a base 16 representation or hexadecimal, kind of the same thing, representation. It's taken all the zeros and ones of the data and it's just turning it into something a little more human readable. And in this example, we have 157 bytes, or about 630 bits. And I broke it down into the 5 sections. And there's 5 things that we need to understand about what's inside of a transaction. And then in addition to that, there's also just some admin information. These admin bytes are really just to help the full nodes stay organized and keep track of where they are and separate these different segments. So we need to understand, so it's these 5 items we need to understand: the ID, index, digital signature, the amount, and then the public key hash that also got a locking script involved. This was a little extra content at first. So every transaction is linked to a previous transaction, with the exception of the Coinbase transaction. We're not going to cover it now, but the Coinbase transaction has no predecessor. It's where brand new coins are issued for the first time. And the most recent transaction, which hasn't been spent yet, is called an unspent transaction. And in this transaction here, we have Bitcoin was sent from this public key hash to this public key hash, and this is called the output. And this can be somewhat confusing because when this transaction, when this output now is spent again in another transaction, it's going to be called the input, and then so on. And then another source of confusion is every single raw transaction has its own transaction ID, which is essentially takes most of this data, sometimes all of it, not always. It runs it through the SHA-256, and you get this output, which is then included in the next transaction in the line. And the unspent transaction go by their own name called UTXOs. So let me go back. So this, as an unspent transaction, is going to go by its own name, which is called a UTXO, which is an important role. We're gonna cover it shortly. So there's just a lot of various items going about when it comes to transactions. So we're gonna use this video to organize them, and and then the last piece before we get any deeper is these two outputs are connected, or this amount of Bitcoin arrived at this address after it was sent by this address, and here's where the digital signature comes in. So the private key is applied here. The private key, it's a pair with this public key, and this is one of the things that the network checks before validating and propagating the transactions. So let's walk through, from what we know now, what a transaction would look like. And we're going to start with what Alice has. So Alice has the latest transaction in the series. It's called an unspent transaction output, which consists of, you know, the picture we just saw, basically. And this top portion, the previous UTXO, and this signature, we no longer need them for this next the transaction. So now we have a transaction ID. We have the transaction ID. We have some amount of Bitcoin at her address, and we have this condition called a locking script, which is essentially saying she needs to prove she has the private key in order to send the Bitcoin at this address. So Alice has the private key that will allow her to satisfy this condition and send this amount of Bitcoin to any other address that she wants. So now from Bob, Alice gets his public address, you know, where he wants her to send the Bitcoin, where he wants it to go. And now she's going to start creating the transaction. So recall that Bitcoin uses the ECDSA, and Alice has her secret key. This is the A. She's going to make the K, making sure that an inverse mod Q exists. And the M is going to be a hash. The M here is going to be a hash of most, you know, might not be all of this, but it'll be most of this data is going to create, you know, through a hash will create M. And in using all of these, Alice will sign the message with her private key. So what that means is essentially Alice is going to compute R and S, and this is just an example of what R and S can look like. You know, these are long numbers, and these public parameters, these are commonly known. These are published and available within the SEC. Can't see it here. The SEC P2561 curve. This is what Bitcoin uses. All these parameters are known and widely published in that. So yeah. So now back to our UTXO build. We have this mechanism to unlock this lock. This is the unlock. This is the lock. And we have all the ingredients now to build a transaction. And this is just the here is just the R and the S that we just saw. That's what this piece is of the transaction, the R and the S values. So, and again, the admin is just going to keep this standard and organized for our computers to process, and also lets us know what pieces of this prior output do we need. So these bottom ones here, they're letting us know what pieces of the prior output do we need to hash to make M for our signature. Because this signature here is unlocking the script from Alice's prior output. So I know there's a lot going on here. There's a lot to look at, but this is the transaction that Alice made, and this ID here points to her UTXO, which in turn is going to point to her address on the blockchain. And it's this, and then this section here provides proof that Alice owns the private key of this address that's stored in the raw data on the blockchain. and then down to the bottom of the transaction, this is Bob's address, and these are just some admin instructions, basically saying that, hey, Bob needs to prove if Bob wants to receive this Bitcoin and then spend it in the future, he's going to also have to prove that he has the private key to this address. That's all that this admin stuff is doing, the lock. So Alice now sends this transaction, and it propagates, it's making its way across the network. And when it hits a node, the full node has the UTXO data set, the mempool, and the blockchain. And in the UTXO data set, the node has all of the UTXOs stored, and this is just a local database. It can quickly find it. It's going to do that, and it's going to look in the blockchain, and then it's going to find the raw data of of Alice's UTXO. Then it's going to check the R and the S, making sure that Alice is the owner of the private key. And if it's all valid, then the node's going to add that transaction to its mempool, where it's going to wait to be added to the next block. And then the node's also going to, at that point, send this transaction out to all the other nodes, networked nodes that it's connected to. Okay, so this is another look, hopefully maybe a simpler look at a transaction and the components of a transaction. And there's not too many pieces in the transaction. I think where it gets confusing is that there's just these connections to other pieces. Well, that's where the blockchain comes in, and the data integrity. All right, so we need to make a important distinction between the UTXO and a transaction. So this is a more generalized view of what a UTXO is. And in the UTXO itself, there's not too many pieces to it. And that's because you have this transaction ID, and that's pointing to the blockchain, where all the raw data from this transaction is sitting on the blockchain for data integrity. And then you have your secret key here, which is the owner's connection here to that raw data. And the secret key is what allows the owner to send this Bitcoin. So now let's compare the UTXO to a transaction. So this is the same example raw data from earlier. I just compressed it a little bit. And then now we'll take it and we'll make it a little more generic. And this is the information that you have in a transaction. This is the data that so all of this, gets hashed, makes the transaction ID. So this and this, they go out to the Bitcoin network. So in this fashion, the sender is providing the full nodes all the information they need to validate. So full nodes get this. They're going to get this pointer. They're going to find the raw transaction, the prior transaction on their blockchain. They're going to pull all the raw data, and they're going to use that. They're going to, hash their M. They're going to get the R and the S. They're going to ensure that whoever created this transaction does own the private key. And if all of this is valid, then they will process this transaction, add it to the mempool, and send it out to the rest of the network. And if it is a valid transaction, we now end up with a new UTXO. So we have a new address, we have a new owner, we have a new UTXO. And getting a little more into UTXOs, this is a big point. And also, it's about to get, I think, crazy for the next few minutes, so hold on. So every transaction is going to completely consume at least one UTXO, and it's going to create another one. All the inputs of a transaction are going to get completely consumed. So on top of that, a transaction can have more than one output. So you're going to have to add some additional bytes to your transaction, but you can have as many outputs as you want. And and you know, it might increase what you pay for miner fees. Or conversely, you know, you could have 2 inputs and just 1 output. And again, you're going to have to add in this extra input in your transaction data. It's going to increase the number of bytes you need. So you can have as many inputs and as many outputs as you want, all in one transaction. So as promised, now we'll get back to the index number. You know, we have the index number. So we have the index number, and we have outputs. So let's go down to the bottom here of this transaction. This transaction ID is the hash of all, or at least most of this data. It's going to become part of this new transaction. So when you have this transaction ID and you're sending a UTXO, as it pulls this raw data, let's just say, for example, you're going to send the 5th output of that transaction. As an input, you have to identify, here's a transaction ID I'm pulling from, it's this one, and I'm talking about the 5th output of that transaction. That's the UTXO I want to spend. So you got to get that information to the full node. So all right, now, so these are the UTXOs that Bubba owns, and all of these UTXOs reside at the same public address tied to this key. And this is very common. I went on the blockchain and I found an address just a few minutes ago, and it was to show you all this address. So this is the address, BC1SH, and you can see just 11 minutes ago there was Bitcoin sent to this address, BC1SH. 25 minutes ago there was more Bitcoin sent to this address, and then about a week ago there was Bitcoin sent to this address. So these are all UTXOs arriving at this address. And you go down a little bit. So here, about a month ago, there was 1 input, and at the same address, there were several outputs, and several outputs. So it's very common to have an address with multiple UTXOs on it. And think of these like coins that you would think, or that you would keep in a wallet. So in this situation, to buy a lemonade, Bubba can take his coins and combine them and give to Alice, or he can give a large coin and then get change back. And a UTXO is essentially a digital coin. And just like you can't cut a coin in half, you know, a transaction must consume the entire UTXO. And this is where the term Bitcoin comes from, since all the information in this UTXO is just bits, it's just zeros and ones, and it acts like a coin. So Bubba decides to use these 2 UTXOs, makes his transaction, sends it to Alice. But just to note, we haven't covered miner fees yet, but every transaction will need a total output value that's just a little less than the total input value. But more on that in a future video. And so now to go to another website called Glassnode. Let me move this up. And I will expand this so maybe we can all see it a little better. Okay, so on this website you can see information about UTXOs. So okay, so here is from March 24th, so it's about a month ago. So on this website you can see on this day all the UTXOs that were created. So that was about 1.2 million UTXOs created, 1.1 million UTXOs spent, and then the total amount of UTXOs in all of Bitcoin is almost 223 million UTXOs in total that exist of the 20 million something total coins. And then all of the UTXO information is stored locally on each full node. So this is just like a regular database, like an Excel sheet, because it's very fast to access. And the total number of UTXOs, is just always changing from a minute to minute, hour to hour basis, since UTXOs are always being consumed and created. And there's all different ways. You can have several inputs, several outputs, one input, several outputs, and so on. And in addition, so one last thing from mempool.space. Let's go back to the dashboard, back to the latest block. So we can see here, the last block we had the fee that was paid to the miner. This was 3.125 plus 0.394, and this was part of the Coinbase transaction. And we haven't covered this transaction yet, but there's no prior UTXO of this transaction, and it's creating, well, in this case, essentially two new UTXOs are being created at that miner's address. So UTXOs are the cash that is used in Bitcoin. They are the Bitcoins. And you have transactions will consume UTXOs and also make new ones. And most, sometimes all of the raw data in a transaction will be permanently stored on the blockchain after a full node validates it and a miner gets it in a block. And then the UTXOs are stored just in a regular database at each full node. So the blockchain actually has two pieces to it. There's the data integrity blockchain, and then there's the UTXO database.